So good afternoon or good morning, depending on where you're joining us from, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world, and we are particularly excited this October. Not only are we doing more sessions than we've ever done in a month in history, so 60 sessions this month, which is crazy, but we're doing about 40 of those on amazing space research. So October is our entire month dedicated to space. We've got astronauts, astronomers, engineers, research scientists, pretty much everyone you can imagine that is pushing the boundaries of space exploration. So it's really exciting. Thank you guys so much for joining us. All right, we've got 7 classes joining us from across North America. They're literally everywhere today, which is great. So I'm going to give them a chance to say hi. We've got Ms. Hans's class, grade 6s in Austin, Texas. Hi, guys. Hey. We've got Julie's class at the Ontario Science Centre School, grade 12s in Toronto, Ontario. Hi, guys. Hey. We've got Miss Exdall's grade 5s in Forest City, Iowa. They might be changing over. They're coming in. Hi, guys. Hey, that's an enthusiastic changeover. We've got Mr. Sahadio's grade 6s in Peterborough, Ontario, joining us for the very first time. Welcome in, guys. Hey. This is already a great hangout. We've got Miss Burkett's grade 5s in Sterling in Virginia. Hi, guys. Hey, there's so many of you. Why are there so many? What did they do? They got the whole school involved. We've got Mr. Gulahar's grade 5s in Bernie in Texas. Let me just demute their mic. Hi, guys. Hey, and last but not least, we've got Miss Heights grade 3 through 5s in Snohomish in Washington. There's so many. Perfect. All right, we've got everyone in today. Of course, the reason you guys are all here today is for our speaker. So we are joined live in Pasadena, California by Abigail Fraeman. So she is a research scientist at NASA's Jet Propulsion Laboratory, which is one of the most storied and iconic and amazing science facilities in the whole world, literally leading to most of the space developments we've had in the last 50 years. So what she's going to do is tell us a little bit about her job today. And she gets to study rocky bodies, asteroids, planets, moons, all throughout the solar system and understand them with probes and rovers. So she sends the most cutting edge technology out to other bodies in our solar system and understands and gets to see places in the universe before anyone else gets to see them. So probably the coolest job in the whole world. Without further ado, I'm going to turn it over to you, Abigail. Thank you so much for joining us again today, and take it away.
Hi guys. Oh, I'm so excited to be talking with you today. This is wonderful. Yeah, so I'll just start off, talk a little bit about myself, what I do, where I work, and then really excited to hear your questions about space and anything you can come up with. So I'll go ahead and share my screen because I have some pictures to show. So let's try doing this. Let's put this in presenter mode. Can you guys see my screen all right?
Yep, you're great.
Great. Okay.
I was muted.
Great, awesome. All right. Yeah, well, thank you again so much for having me. I'm really excited to talk to you about what I get to do for my job every day, which is explore Mars. But I don't work at Mars. Mars is a little bit far away. Instead, I work at this lovely place called the Jet Propulsion Laboratory. We're located in Southern California on the west coast of the United States. And we've been around for about 60 years now. We're a bunch of buildings kind of nestled in the mountains. And the sorts of things that we do at the Jet Propulsion Lab, or as we like to call ourselves, JPL, specialize in robotic exploration of the solar system. So we have built spacecraft that has traveled from planets throughout the solar system from the sun past Pluto. JPL is part of NASA, and I'm sure you guys have all heard of NASA, which is the space agency of the United States. JPL is not NASA. NASA is actually a collection of centers located across the US. So you can see down here in the corner, I'm located here on the West Coast, again in Southern California, but there's centers all over the country. So some of you guys were in Texas. There's a NASA center in Texas in Houston called the Johnson Space Center. And they specialize in human space flight. So all of the astronauts, the quotes you might be familiar with, Houston, we have a problem. That's all down in Texas. There's Kennedy Space Center in Florida. That's where all the rocket launches occur. There's Langley Research in Virginia. Some of you are from Virginia as well. So NASA is actually all over the country. But as I mentioned before, I work here at the Jet Propulsion Lab, which specializes in robotic exploration of the solar system. We go all over the solar system, but in particular, I'm really interested in Mars, which is the planet that's right next door to us. It's called the red planet because it's red. And it's a really interesting and exciting place to study. And here's why. First, we like to want to study Mars because it's a wonderful place to help us understand whether we're alone in the universe. Right now, the only planet that we know has life on it is Earth. But we know that there's lots of planets in our own solar system and planets orbiting stars, making other solar systems really far away. And so we're really curious, is Earth really the only planet out of all of these thousands of planets we know about that has had life? Mars, we think, was once like Earth. And we think billions of years ago, the two planets were really, really similar. And we think that the conditions that may have led to the emergence of life on Earth could have existed on Mars billions of years ago as well. So we go to Mars and we are exploring Mars and we're looking to see if there's any evidence that there's life on Mars. We haven't found any yet, but we're still looking, and we think we're getting better and better in understanding what to look for and how to look for it. So the search for life on Mars, I think, is one of the most profound questions we can ask. And think about it. If we find that there's life on Mars, that tells us that life across the universe is probably a pretty common process. We found it in two planets in our own solar system, and that would probably really change the way we think about the universe. I'm also really interested in Mars because it was so similar to Earth in the past, but now it's very different. The surface of Mars is very, very cold. The atmosphere is very, very thin. There's no magnetic field to protect the surface from radiation. It's not a very nice place to live right now, even if it was a nice place to live maybe 3 billion years ago. So understanding what happened on Mars is really important because it'll help us understand what makes planets habitable and sustains them for being habitable, like happened on Earth, versus what doesn't, like what happened on Mars. And again, kind of understanding how planets work is really important. And the more planets that we find in other solar systems, the more we really need to know what are the factors that make them nice places to live or not nice places to live if we're looking for life. And of course, one day we're going to send humans to Mars. It's going to happen. It's going to be amazing to be able to walk around on the surface and explore it. And before we do that, we really need to understand what kind of environments we're going to find. We need to understand what resources we might be able to find on Mars in order to support humans. And so all of these studies doing now with robots are really important. And hopefully this will happen soon, and maybe one of you guys will be the humans who get to go to Mars. I hope so. But before we send humans to Mars, we can also do a lot of things with humans here on Earth. So one of the ways that I study Mars is by studying its geology, looking at its rocks to understand the sorts of environments that formed the rocks, that affected the rocks. And while I can't go walk around on Mars to do that, I can do that here on Earth in sites that are very similar to Mars. So here's some pictures of me in some of the really cool places I've gotten to go to study because they're similar to Mars. Places like deserts right here in Southern California, places like Iceland, which are really cold and have rocks that are made of the same things that Mars rocks are made of. Places, again, like dry environments in the American Southwest. So all of these field sites are important to go to in order to interpret what we find in the rocks. And it's a lot of fun. I like to travel. I like to be outside. So for me, this is really a perfect job. But of course, the rocks I really want to study are on Mars. And since I can't go there myself right now, I use robots to study Mars. And a lot of these robots, again, are built by the Jet Propulsion Laboratory. But a lot of them are also built by other countries around the world. Europe has a few orbiters that are looking at Mars. There's one from India. Next year, we're going to have the United Arab Emirates is sending an orbiter, China sending an orbiter. So it's really a world effort that we're putting into studying this fascinating planet. Here's a picture of some of the satellites that the United States and one European, this Mars Express, have sent to Mars that are currently operating or have operated in the past that we used to study the planet, orbiters looking down at the surface. And from orbit, we can get these spectacular pictures of what the rocks look like on Mars. Here's just one example of this amazing camera that's really high resolution. We get 25 centimeters, so about this big area per pixel in this image. So we can get really, really detailed and see really small things on the surface. And we can see these amazing layered rocks that tell us information about history as it changed through time. We can see these big sandy features. Some areas on Mars are just these beautiful sand sheets of this really dark, we call it basaltic sand, kind of like sand that you might find in Hawaii or Iceland or places where you have a lot of volcanoes. And also from orbit, we can not only see what's on the surface, we can map the composition of what's on the surface. So this is a picture of a feature that's called a delta. And what that is basically there was a river that was traveling along from the left side of this image, and it came into a big lake and it deposited all of the rocks and stuff that it was carrying. And it made this sort of fan-shaped feature, which you can kind of see here. And it formed this beautiful delta. And so we can see the picture of the delta, but we can also see the minerals that make up the delta. We see things like clays and carbonates. And in fact, this particular delta is so exciting, and the minerals we see there are so interesting that we're going to send a rover to study the area next year. It's going to launch next summer. Right now it's called the Mars 2020 rover, but we're looking for a new name for this rover, and we're asking students like you guys to solicit your input. So if you have ideas for what would be a good name for the next Mars rover that's going to study this delta, NASA wants to hear from you. And you can actually write an essay and enter a contest to name it. I think for the next couple of weeks, they're accepting entries. So you can look that up online. It's pretty exciting. But I've done a lot of work on the rovers that have landed on Mars in the past, and several in particular I want to talk about. The first are the Spirit and Opportunity rovers. Those landed on Mars 15 years ago, back in 2004. And there were two rovers, again, named Spirit and Opportunity. And these were they were the second rover we landed on Mars, but they were really the first ones that had a lot of really good scientific equipment that we could use to study the rocks. The equipment on Spirit and Opportunity was kind of like the tools that I use as a geologist when I go out into the field here on Earth. We had a tool that could grind into the rocks that was like a rock hammer. We had a tool that we could use, a microscope basically on the end of this arm that could look up close to rocks. We had a camera, of course, to take pictures, and a few other instruments that could tell us about the composition of the rocks. Now, when Spirit and Opportunity landed on Mars, one of our biggest questions was whether there was ever liquid water on Mars. As I mentioned, Mars today is very cold, very dry, but we thought in the past, perhaps it was once warmer, maybe it had a thicker atmosphere, and maybe it had liquid water on the surface. And liquid water is very important because life as we know it here on Earth absolutely needs liquid water. So we wanted to see if there was evidence of liquid water on the planet in the past. When Opportunity first landed, we found these amazing layers of rocks. We saw them exposed in these big walls and the walls of craters. And when we looked up close to the rocks, we saw these little tiny balls. They kind of look like alien eggs, but I promise you they're not. They're actually made of iron, and they're features called concretions that form only when you have liquid water. So this was some of the first evidence we'd ever seen way back in 2004 that there was once liquid water on the surface of Mars, and an Opportunity found this right away. It was so exciting. What we think the setting at that site was probably like was something like this picture, where we had shallow pools of very salty water that came up from the ground and was kind of intermittent. Sometimes it was wet, sometimes it was dry, and it got really salty. And this is a place, it's a little bit tough for life, but it's somewhere you might be able to find life. Opportunity went for a really long time. The rover was supposed to last for just 3 months. It ended up exploring Mars for over 14 years. But last year, there was a big dust storm that covered the entire planet. And when it did that, it blocked out the sun. So here's a picture of what the sun usually looks like for the rover. And all the way on the side, where you can barely see the sun, that's what it looked like in the middle of the dust storm. And this is really bad for Opportunity because the rover is solar powered. So when you have no sun, you don't have any power, and the rover lost power, and we were never able to reestablish contact with it. So the mission ended last year after, again, 14 years, which was pretty spectacular. This is a really special mission to me because it was the mission that really inspired me to study Mars in the first place. This is one of the first pictures that Opportunity sent back. And it was so exciting. And in particular, the scientists were so excited about these rocks in the background, and they were jumping up and down saying that this is bedrock, this is bedrock. And when I saw this first image, I was in high school. I didn't know what that meant. But I wanted to learn, and I wanted to understand why they were so excited. And so I went to school. I got my undergraduate degree in physics and in geology. And then I went on to grad school where I got a PhD. And I learned why the scientists were so excited by this finding. Here's just a picture of me. I actually got to be at JPL. And so there I am. I'm an 11th grader in high school, seeing the image come back for the first time. And it was so exciting. And just to give you a sense of how long this mission lasted and everything I did, here's a picture of Opportunity's traverse on Mars. So everywhere it drove with my career milestones. So, you know, we landed all the way up here, all the way up here when I was a high school junior. I graduated high school. I started college. I did some summer research internships while I was in college, where I got to work with the data from Opportunity. I graduated college. I went to graduate school. As a graduate student, I actually got to start working on this rover because my advisor, my kind of graduate school boss, he was the guy who was in charge of it. Ended up getting a master's degree. Then I got my PhD. Then I started something called a postdoc, which is what you do after your PhD for a couple of years to kind of establish yourself as a research scientist. And then I started working at JPL, and the rover was still going. After a couple of months here, I was appointed as the deputy project scientist for the mission, which I did for 3 years until the mission ended last year. And it was so exciting to be able to do that for this particular mission, which inspired me. Right now, I do a lot of work on the rover we sent after Spirit and Opportunity called Curiosity. And if Spirit and Opportunity were the robot geologists, then Curiosity is our laboratory scientist. There's a lot of fancy instruments inside of the rover that can do really detailed analysis of the rocks. There's also a laser on the rover's head that we can use to shoot the rocks and figure out what they're made of. That's a really cool instrument. Here's a picture of just the size of Curiosity compared to, here's our first rover in the bottom, and then here's Spirit and Opportunity over here, and Curiosity is just this giant rover. It can do a lot of really good science. We landed in this big impact crater that was very special because in the middle of this crater there was a mountain, and we could see from our satellites that there were layers in the mountain, and we wanted to study the layers. Here's what the mountain looks like when we landed. It was off in the distance. We had to land kind of where it was flat because that's where it was safe. But ever since we landed, we've been driving towards and now up that mountain, studying the rocks. We found rocks that have these really well-cemented rounded pebbles in them. We think these rocks formed in streams, similar to what you might find on stream rocks on Earth. And then when we looked at the mountain with our telephoto lens, even from far away, we could see these beautiful layers. And then we got really close and started climbing the mountains. We could see these layers are these really, really fine layers made of really, really tiny grains. And all of this was telling us that this crater was probably once fed by a big river that again emptied into a lake. And we think, in contrast to Opportunity, where there was salty water, here we think there was fresh water. And we think this lake must have been around for millions of years. So we think that this would have been a wonderful place for life to have lived. We think it was a very habitable environment. And so our next rover will go to Mars to look for clues as whether there was ever life. One of the other exciting things Curiosity found were organic molecules. These are molecules that have carbon in them. These are the building blocks of life. So we found a place where life could live, and we found the building blocks of life, which is very exciting. Just for fun, here's a picture that came down from the rovers this weekend. And it's true, I get to see the Mars data as soon as it arrives on Earth, but actually it turns out that you guys can see that data too. And I'll put these links up for just a little bit. But all of the pictures that we take with Curiosity are posted online in real time. So you guys can log on and look for the raw images from Curiosity. You know, as soon as they come down from Mars, and you can see them as soon as we see them here at JPL. We also write a blog every day that we operate the rover, which is most days of the week. We have a couple paragraphs describing what we did, what we're up to. So if you're interested in following us along with real time, check out the mission update blog, and you can explore with us real time. All right, and that's all I have to share. So I'll go ahead and stop sharing my screen, and I'll look forward to answering questions from you guys.
Outstanding, Dr. Fraeman. So that was amazing. And I'll pass along all those links to our classes too in an email at the end, so you can look forward to those, so you don't have to look them up yourselves. Yeah, let's dive in. We've also got a bunch of groups watching on YouTube Live, so if you guys want to type in your questions in the chat bar, I'll happily pass them along. But yeah, let's dive in. We'll start with Ms. Hance's class. If you guys want to kick us off with a question after that awesome presentation, go right ahead. Yeah, there you go. Yeah, you're good to go.
How long did it take for each of your rovers to get to Mars?
How long did it take? Yeah.
How long did it take for the rover to get to Mars? Well, it depends on how you launch it and where you launch it. We like to launch the rovers when Mars is closest to Earth, which is something that happens about every 2 years. And when we launch that way, it usually takes about 6 to 9 months to get there. So the longest road trip you've ever been on.
All right. Now, out of curiosity, actually, quick follow-up. You talked about humans going to Mars. Is there a way to get them there, going there faster? Would it be slower? Would it depend?
Yeah, we're going probably about as fast as you can go in order to get to Mars. You know, if you put a really big rocket, maybe you could get there a little bit faster. Of course, when you want to send humans to Mars, you want to go as fast as you can, because when you're in space, you're exposed to a lot of radiation, which is dangerous. So you want to stay, you know, minimize your time that you're exposed to radiation as best as you can.
All right, perfect. Let's go to Julie's class. You guys have a question in Toronto? Come on up.
Julie, that's you.
That's you. Yeah.
Hey, this is from one of our group. So we've heard that some of the crew who worked with the rover adjusted their work hours to match the Martian day. Is that so? And do you have to? Did you have to do this, Abigail?
Yeah, I actually did. It's something we did when the rover first landed on Mars. For about 3 months, the entire team lived on what we call Mars time. The way we operate the rover is every day we come up with a plan for what we want the rover to do. We send that plan to the rover in the morning on Mars. The rover spends all day doing the thing that we asked it to do while we sleep. And then at night, the rover sends us back everything that happened. While the rover sleeps, we plan the next day. This works out great, except Mars has a 25-hour day instead of a 24-hour day. So when you want to stay on this schedule, you have to shift your schedule by an hour every day. So when you're on Mars time, you come in, 9 a.m., then 10 a.m., then 11 a.m., and pretty soon you're working at 2 in the morning. It's a lot of fun. It's a lot of fun for a short amount of time. We had things where we would get off at 8 in the morning and we'd have a barbecue during breakfast time because it was our dinner time. But it's hard because it's very isolating from the rest of the world. It's not a set schedule. So after about 3 months, when we get really good at operating the rover, we switch back to Earth time. And what happens when the schedules don't line up, we'll just plan 2 days at a time for the rover, or 3 days if it's a weekend. So that's what we've been doing now for the last, oh gosh, 7 years.
Great question. Really insightful. Way to go, guys. Looking that up ahead of time. All right, Ms. Eggsdall's class, come on up, and you have a question? Go for it. Hey. Yep, you're good to go.
Second favorite planet.
You have a favorite planet?
Well, so the second favorite planet, you'll actually probably be surprised. My second favorite planet is probably Mars, because my first favorite planet is this planet right here. It's Earth. I really like Earth. It has everything I need to live. It has all my friends, all my family. It's a really cool place. So Earth is probably my absolute favorite planet, but Mars is a close second.
Yeah, awesome. All right, Mr. Saadio's class, come on up, guys.
Okay, go ahead, Mr. Caleb.
How long did it take for you to get to this point of your career?
How long did it take to get here? It took a lot of school. So as I mentioned, after I finished high school, I went to 4 years of college for undergraduate. And then I went to 5 years in graduate school where I earned my PhD. And then another 1.5 years for my post-PhD postdoc. And then I got hired at JPL. So it was a lot of school, but I love school. So it was a lot of fun for me. I really like learning things.
We can tell you are the most passionate person. We do so many of these. You're the best. This is so much fun. All right, let's go to Virginia. Ms. Burgett's group. You guys have a question? Come on up.
Why were scientists excited about the bedrock?
Why were the scientists excited about the bedrock? Great question. So it turns out when you have just a random rock lying on the surface anywhere, it can tell you interesting things, but it can't tell you everything because you don't know where it came from and you cannot put it in context with all of the rocks around it. When you find bedrock, that is rock that is in place where it formed and it's surrounded by other rocks that formed around the same time. So you get a much bigger picture about the full story. So it gives you more geologic context. So it told a much richer, more detailed story.
Okay, very cool. You know what, Ms. Burgett's class, you guys have like so many students that it's like a whole school's there. So I'm going to take another question from you guys and then we'll keep going that list, okay?
Right here.
How do you know when the rover is ready to operate?
How do we know when the rover is ready to operate? So there's 2 ways. We keep a very detailed schedule of what the rover's doing. And in that schedule, we keep track of how much power it has, when it needs to go to sleep, when it needs to go to wake. But the rover also talks to us. And every time we have a scheduled communication with us, it'll send us a little beep and it'll say, hey, I'm here, send me instructions. And 99% of the time, our schedules match when we hear from the rover. And so we know everything's good. If something doesn't work and there's a problem with the rover or a problem with the communications, that's when things get a little complicated. But there's a lot of fancy software on the rover that keeps it safe. And in the event that we don't manage to connect with it, helps us pick it up again a little bit later.
Very cool. Great question, guys. All right, let's head to Texas. Mr. Gallahar's class. You guys have one? Come on up.
Can the rover dig underground for bones or water?
Can the rover dig underground? That is an excellent question, and actually something a lot of scientists are talking about. So right now, Curiosity does have a drill, but it only goes maybe that deep. So we can get a little bit underground in order to drill into the rocks. There's another mission that JPL just landed on Mars, a couple months ago, that has a really cool instrument called the Mole. And the goal of the mole is to actually get down about 18 feet into the surface. And it wants to measure the temperature, how warm Mars is that deep. And that tells you something about the inside of the planet and how it lost its heat. Unfortunately, they're having a little bit of trouble with that instrument. It kind of got stuck just a few centimeters into the surface. But they're trying all sorts of tricks to try and see if we can get it a little bit deeper. So fingers crossed that'll work. There'll be another rover that Europe is sending next year called the Marie Curie rover, which is a great name, awesome female scientist. And Marie Curie also has a drill that's supposed to go very deep, tens of feet, I think. Drilling is really hard, so we'll see if it actually works. But if it does, again, it'll help us understand what's underground on Mars. And in fact, we think if there is life on Mars today, maybe it's actually living underground because that's where it's protected from radiation. And if there is liquid water, it might still be underground. So it's an exciting place to think about looking.
Yeah, I'm really glad we got a drill question too. So I'll pass this along to our students as well. We did a session with Ravi Prakash, who's working on or talking about a Europa mission and going under the ice on one of the moons out there. So just check that out as well. And drilling is going to be a really big part of scientific exploration for years to come. So that's a great question.
Definitely.
All right, Ms. Height's class, let's go to Washington. If you guys have a question, go for it.
So go ahead, Bryn.
Do you think that if there was life on Earth, it would be underground? Mars?
Life on Mars? Yeah.
Yeah. So, well, first of all, we do know that there's life on Earth underground. And in fact, scientists just discovered like a month or two ago, life in a really, really deep mine. And it was in an environment we didn't think there would be life because it's pretty deep. It's very warm, but we found it living really deep on Earth. So absolutely, we think, that might be one place to look. It turns out too, Mars is great because you don't necessarily need to dig real deep underground because Mars has these big impact craters. So big meteors came in and hit the ground really, really hard. And they actually brought up a bunch of rocks from really deep. So we might be able to see what's underground on Mars without actually having to drill by sending rovers to big impact craters. We might also get a glimpse into the subsurface of Mars.
Very cool. All right. Let's head back to Ontario Science Center School. So Julie's class, if you guys have another one, come on up.
Yes, we do.
Yes.
Yes.
So you mentioned that the iron pellets are spheres because of liquid water. Is there any chance that it could be a different liquid?
That's a really good question. Could we have liquid that wasn't water? We think it's probably water because they're very similar to little spheres that we find on Earth that are formed in water. And we don't see anything in their chemistry that would suggest that there was another liquid that was present. Also, we don't know what the liquid could have been given what we think the temperatures of Mars were. But there are other places in the solar system where absolutely you have liquids that aren't water. So for example, one of the moons of Saturn called Titan is so cold, there's actually liquid methane. Methane is usually a gas, but it's so cold there that it's the liquid. And there are these rivers and lakes filled with methane on Titan. And actually NASA just announced they're going to be sending a octocopter. It's like a drone. It's a quadcopter, but 8 rotors to Titan, and it's going to land on Titan, and then it's going to fly around and explore these methane lakes and rivers. And that's going to be so cool. The chemistry is going to be crazy. And that's probably going to happen, I think, in the 2030s. So, by the time some of you guys are finished with your schooling and ready to be scientists, you can work on this mission that studies the moon of Saturn and explores these methane lakes, which will be so cool.
How cool is that? Abigail, you might be able to tell us, what was the mission that actually went through the clouds and saw the shoreline for the first time? Is that I can pass along images of that to our students?
Yeah, so that would be the Huygens probe on the Cassini mission. So there was a mission called Cassini that was also managed by JPL, which went to Saturn and explored the Saturn solar system, or the Saturn system, so the planet and all its moons and the rings for many, many years. That mission also just ended a couple years ago. But one of the things that it did when it first got to Saturn was it sent a probe into Titan. It was kind of just a one-way trip, but it was called Huygens. And it sent back some amazing pictures of these shorelines.
All right, so I'll pass those along too. Thank you so much. All right, Miss Eggsdall's class, come on back up for a second question.
How does gravity work on other planets?
Ah, good question.
Yeah, how does gravity work? Well, it works similar to Earth, but I think you're picking up on something. Gravity is actually how much gravity you feel is related to how big the planet is. So when you have a really big planet like Jupiter, gravity is really, 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 really strong. So if you were to stand on the surface of Jupiter, you would feel like you weighed a lot because there would be a lot of gravity. On Mars, the gravity is a little bit less because the planet's a little bit smaller than Earth. So it's about a third the gravity that we find on Mars to what Earth. So you would weigh about a third of what you do if you stood on the surface of Mars compared to the surface of Earth.
Very cool. So how high could you jump? Is there like a basketball games set in the future on Mars?
No, there should be.
Okay, we'll make that happen.
Probably a lot higher, yeah.
All right, Mr. Zahadio's class, if you guys want to come up for a second one, go for it.
Yeah, we're coming.
Yeah, take your time.
If there was life on Mars, would there be plastic there?
If there was life on Mars, would there be plastic? That's a great question. I don't think so. Unless the life had some sort of process that made plastic as a byproduct of their waste. Or, maybe if they were really intelligent and they made plastic making factories. But we haven't found any plastic on the surface yet with our rovers except our own. In fact, when Curiosity first landed, we saw something really weird on the surface, and we called it a FOD, a foreign object debris. And we spent some time actually investigating it and taking pictures of it. And we think it was actually a little piece of plastic that fell off the rover that we left littering the surface of Mars. So I think the only plastic that's on Mars is plastic that we left there.
Yeah. Well, actually, you come to a really good point with that. Great question. How do we try and avoid contaminating Mars? This is something that comes up in a lot of our Mars talks, is how they prepare the spacecraft for that. And
yeah, we have something we called planetary protection, which means a couple things. First, it means protecting Mars from us. So when we send rovers with really sensitive instruments to detect life, we need to work really hard to make those rovers as clean as we possibly can. So we build them in a very fancy room where when the people building them have to wear very fancy suits that kind of prevent their hair and their skin cells from getting on the rover. When we can, we bake the parts to really, really hot temperatures in order to kill anything that might be living on there. And we just really clean it the best that we can. We also have rules that we try not to send rovers to places that might have any liquid water near them. So if, icy areas that might get warm enough to melt, we don't want to go there just yet because we don't want to accidentally contaminate it and then discover life. That's our own. And the other side of planetary protection is protecting us from Mars. So we're hoping in the next few years to actually get a rock from the surface of Mars and bring it back to Earth with our rovers. And we want to make sure we don't accidentally, if there's life there that we don't know about and bring back to Earth and it makes everybody sick, that would be bad. So we are very careful about how we transport that sample and how we store it, and we put it in very, very tight areas to make sure that whatever we have in there is contained. I think the probability of anything bad happening is very, 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 very low, but we need to be very, very safe just in case.
I'm really glad you brought that up too. So for the kids who might not know, when we first went to the moon too, when they came back, the astronauts were kept in quarantine for quite a time, just in case they brought back any microbes that might have hurt anybody. So I'm glad we're taking precautions still. All right, I'm going to go to Mr. Gallagher's class, and then we'll head back for our other two. So we're going to take about 3 more questions, guys. So take us away if you have another one. Go for it, guys.
Do you ever think that you'll find opportunity?
Oh, will we find opportunity? Well, we know exactly where we left opportunity when we can actually see opportunity with the cameras on the orbiter. So we know exactly where the rover is. It's probably not going to get buried in dust or sand, even though there are these big dust storms on Mars. The dust that it lifts is really, really fine. It's kind of like smoke. So it's not going to bury the rover. It's not going to knock the rover out. Do I think we'll ever be able to reestablish communications with Opportunity? Unfortunately, no, I don't think so. I think at this point, it's now winter. Actually, I think yesterday was the official start of winter where Opportunity is, and it is just too cold, and the electronics can't survive in the cold without heaters. So there's probably metal joints that are breaking, and the battery is probably all drained. So I don't think we'll ever hear from Opportunity again. But maybe one day we'll send some humans there that'll be able to go walk up to Opportunity, fix her up, and see what happens. That'd be pretty cool.
Super cool. All right, Miss Heights class, you guys have another one?
Sure. Opalani.
Who made the rovers and how do the rovers work?
Oh, who made the rovers and how did they work? Well, all the rovers on Mars right now were designed by people here at JPL, and the pieces on the rover, some of them were built by JPL, some of them were built by companies that we contracted with to design things like the motors and the joints and the nuts and the bolts. And they built all these little pieces, and then we assemble and build everything actually right across the street from where I am right now. How do the rovers work? They are so complicated. There are so many bits and pieces on them. I don't think there's a single person who knows everything about all the bits on the rover. But kind of broadly, they're all autonomous. We can send them a series of commands basically once a day, and the rover has a computer on board that can process those commands, and the computer knows how to turn the motors, how to move what we need moved, how to keep the rovers warm, and so all of that works together in order to make it work. It's kind of, if you've ever had the opportunity to build Lego sets or robotic sets, it's really similar.
Right, fantastic. And we're gonna go one more question, Miss Burkett's class. Let's go back to Virginia. Come on up, guys.
Are the rovers AI intelligence?
Ooh.
Are the rover AI intelligence? Actually, a little bit. So the rovers can't completely think for themselves. We tell them most of what to do, but we have a little bit of AI on the rover for a couple processes. Driving. We can actually program the rover to drive itself. It can take pictures of the terrain and figure out where things are dangerous and where it shouldn't drive. And it can also sense how it's driving. And so we can say, hey, rover, go over there, and it'll figure out how to get there all on its own. We need to do this because it takes the signal about half an hour to get from Earth to Mars. Maybe 10 minutes if it's close, but it's still too long to be able to drive the rovers real time, because by the time we'd see where it was, it'd be, 10 minutes, 20 minutes later. So yeah, the rovers can drive themselves if we tell it to. We can also tell the rover exactly where to drive, depends what we want to do. The rover also has a little bit of artificial intelligence for selecting science targets. So for example, sometimes after the rover does a drive, but before we get the data to see where it is, but if there's a little bit of time left in the day, we can say, rover, find some rocks to shoot with the laser that you think are cool, and it'll do it for us. So the Curiosity can pick rocks that it thinks are interesting and shoot them with the laser on top of it. So that's a lot of fun.
Outstanding. Dr. Fraeman, this has been amazing. You gave us a bunch of resources where kids can learn more that I'll pass along in an email. Is there any last message you want to share for kids who might be interested in space, how they get involved, how they learn more, what they can do to foster that sort of passion?
Great. Yeah. I think space exploration is so much fun. And if you love space, there are so many ways that you can become involved. You can be a scientist like me, doing geology or chemistry or biology or astronomy. All of those are needed for space. You can be an engineer if you like building things and building robots, but you can also do a lot of other things. We have people who need to help us with our business contracts if you like business. We always need communicators and storytellers. So if you like writing, if you like English, we really need those sorts of people too, because, you know, what's the joy of exploring space if there's no one to tell the story of what we do? We need artists to share to the public kind of what we find and what we're thinking about. So there's all kinds of careers that can become involved in space, and it's really pursuing what you're passionate about and what you love doing that I think will get you to places you really want to be.
Outstanding. Well, thank you so much for a fantastic presentation again. What we do at the end of every session, so boys and girls, if you guys get ready to join me in saying a huge thank you to Dr. Fraeman, I'm going to demute everyone's microphone in just a couple seconds, and then we'll dive right in. So yeah, Mr. Sahadio, Ms. Exdahl, Ms. Height, everyone's class should be demuted. But awesome, guys. Yes, do look out for that email in a minute. Dr. Fraeman, thank you so much. This was fantastic.
Awesome. Thank you guys so much. You asked such good questions. This was
Yeah, it was a really great session today.
Thank you.